Hello everyone, this is Sangame. So today I'm going to discuss about the machine design. In this lecture, I'm going to discuss about the basic machine design procedure, types of design. Okay, so do subscribe for the latest lectures of machine design. So first of all, let us see what is machine. A machine is a device which receives energy in some available form and utilizes it to do some particular type of work. It is also it is also called as the mechanical structure that uses a power to apply the forces and to control the movement to perform an intended action. Let us see what is machine design. Machine design is defined as the use of scientific principles, technical information and imagination in the description of a machine or a mechanical system to perform a specific functions with maximum economy and efficiency. So the design engineer should possess the knowledge of scientific principles, he should have good technical information, he should have the well imagination power for the description of machine or a mechanical system which is going to perform a specific function. Obviously that function it should perform that function with a maximum economy and efficiency. So this definition of machine design contains the following important features. A design engineer uses principles of basics of engineering and sciences such as physics, mathematics, statics, dynamics, thermodynamics, heat transfer, vibrations, fluid mechanics. Some of the examples of these principles are Newton's law of motion, D'Albert's principle, Boyle's and Charles' law of gases, Carnot cycle and Bernoulli's theorem. Okay, so here you can see the video of engine. So to design engine, the design engineer should have the knowledge of basics of engineering, that is engineering mechanics, thermodynamics, heat mass transfer, vibrations, kinematics, statics. Also he should have the knowledge of mathematics, heat and mass transfer. The designer should have the technical information of basic elements of machine. Obviously most of the machine includes the basic elements like fastening devices like screw, nut, bolt, etc., chains, belt, gear drives, bearings, oil seals, gaskets, springs, shafts, keys, couplings and so on. So a machine is the combination of all these basic elements. So the designer should know the relative advantages and disadvantages of these basic elements and their suitability in different applications. The designer uses his skill and imagination to produce a configuration which is combination of these basic elements. However, this combination is unique and different in different situations. The intellectual part of the constructing a proper configuration is creative in nature. The final outcome of the design process, obviously that final outcome will be a description, and a mechanical engineer uses the language of description as a drawing. So description will be in the form of drawing of assembly and detail, that is the drawing of individual component. A design is created to satisfy the recognized need of customer. The need can be to perform a specific function with a maximum economy and efficiency. Obviously most of the right now we are dealing with the if you take the example of automobile, every person needs a car or bike which is having high fuel efficiency, and also it should have the low cost. Machine design is the creation of plans for a machine to perform the desired function. The machine may be entirely new concept, performing a new type of work, or it may be more economically perform the work that can be done by an existing machine. It may be an improvement or enlargement of an existing machine for better economy and capability. Machine design here according to the problem of customer, a design engineer have to work on that. If the design engineer have to start from the sketch to start the design, it will be the entirely new concept, okay, which is going to perform a new type of work which is not existing market, okay. Or sometimes whatever the function performed by the machine that is not satisfying the right now customer, so in that case the design engineer have to improve the design, okay. So whatever the function performed by the machine, that should be more economically performed. So for that purpose, whatever the design is done, it is actually called as a development design. So design is nothing but it can be anything which is done according to the need of customer. It can be a completely new concept, or it can be a development or improvement in the existing one. Let us see the classification of machine design. So the first type is adaptive design. In most of the cases, the designer work is concentrated with the adaptation of existing design. Means the design engineer utilizes whatever the existing design is there. He used to take the reference of existing design for the development of new design. So this type of design needs no special knowledge or skill and can be attempted by designers of ordinary technical training. The designer only makes a minor changes or modification in the existing design of the product. So second step is actually the second type of design is the development design. This type of design needs a considerable scientific training and design ability in order to modify the existing designs into a new idea by adopting a new material or a different method of manufacture. In this case, though the designer starts from the existing design, but the final product may differ quite markedly from the original product. Sometimes whatever the if suppose the problem is the fuel efficiency of a car, so the designer has to optimize the every component. In that case, he have to redesign, he have to check the overweight, he have to reduce the weight of the overweight components. So sometimes he may have a need of selection of new material to reduce the weight of the component. So that is nothing but the development design. So this is the quite complicated design comparatively adaptive design. So in this case, in the case of development design, the design engineer does some major changes in the existing design, okay, to satisfy the need of customer. Okay. So third type of design is the new design. So this type of design needs a lot of research, technical ability and creative thinking, because in this type of design the design engineer will not have any kind of back reference. There may not be any kind of product existing in the market, whatever the need of the customer, okay, that product will not, if that product or whatever the component needs required by the customer, that may be a new component. So in that case, the design engineer have to start from the scratch. Okay, so only those designers who have the personal qualities of sufficiently high order can take up the work of a new design. Okay, so this is quite complicated type of design procedure, which is difficult comparatively adaptive and development design. So let us see the basic procedure of machine design. The first step is market survey and recognition of need. Okay, so to start the design, sometimes the customer may approach to the organization. He can come along with his problem, and the organization can give the solution to that problem. So, and sometimes the organization have to do the market survey to identify the need of customer. So this is the first step of design, to recognize the need or to identify the need, and the job of the design engineer to convert the need of customer into a technical specification or into the problem or into a problem statement. So second step is the define the specifications of product. At this step, the design engineer have to convert the whatever the need of the customer into technical terms, means in terms of specification of the product. Okay. Third step of design is study of alternative mechanism for the product and select proper mechanism. At this stage, the design engineer have to study the different types of alternative mechanism. He have to compare the various mechanisms and he have to select the proper best mechanism for his machine. Fourth step is prepare general layout of configuration and select joining methods between individual components of the product. At this stage of design, the design engineer have to prepare a general layout of number of components, how many components are there in the machine, and he have to also he have to decide the method of joining of all components, means method of assembly of all components to produce a machine. Fifth step of design is design of individual component. This is very important step. At this point only the design engineer have to work on the individual component. He have to go for the force analysis, kinematic, dynamic analysis of the component. He have to study the effect of forces, effect of load on the component. According to that he have to select the material at this step. Sixth and last step of the design process is prepare assembly and detailed drawing and modify the drawings after the testing prototype model. At this step, when the design of individual component completes, design engineer have to work on the assembly and detailed drawing. He have to work on the detailed drawing of every component, including the part lists, including the machining symbols, limit fits, tolerances, etc. And according to that he have to manufacture one testing prototype model, and he have to check the prototype model whether the model works properly or not. And again if it will work fine, in that case the design will be forwarded to the production department for the final production. Okay, and if it will not work properly, whatever the prototype model is there, and if it will not work properly, design engineer have to go back to the previous 5 steps, and he have to check at what step the problem is there. He have to identify the problem, and he have to redesign the design. Okay, so let's see the first step, that is recognition of need and market survey. At this stage sometimes the customer may come to the organization or the firm which gives the solution to the problem, or sometimes the organization firm have to do the market survey. He have to identify the need of customer. He have to convert that need in terms of a technical problem statement. Okay, the next step is specifications. Okay, the specification is nothing but the technical description of the product. So let us see, I am going to take the example of a scooter. So technical description means while designing the scooter, the list of specification will be like whatever the fuel efficiency of the scooter, what will be the maximum speed, what will be the load carrying capacity along with the luggage, overall dimensions means length, width, height, these also included in the specifications, weight of the vehicle, and last but not least the cost, because every specification, cost is also a part of specification, and every specification or whatever the need of the customer which is converted in terms of specification is totally related with, ultimately related with the cost. If the number of specifications will goes on increasing, the ultimately cost is going to increasing. Okay, and cost is also part of the product specification. In consumer products, the external appearance means a color, form, shape factors are also important for the customer. Noiseless performance and simplicity in operation of controls are important requirements. Depending upon the type of products, various requirements are given, weightages, and a priority list of specification is prepared according to that. So next, third step is selection of mechanism. Once the when the design engineer converts the problem of the customer in terms of a technical specification, next thing is according to the type of machine, the design engineer have to finalize the type of mechanism that he is going to use in the machine. Okay, so here I have given one example of while designing a blanking or piercing press machine, the design engineer have to go for various mechanisms. So I have included the first mechanism which involves the crank and connecting rod. Here the crank is rotated by means of motor, so the rotary motion is converted into reciprocating motion which is given to the punch. So by using this machine, blanking piercing operation can be done. Okay, so alternative to this mechanism is here you can see that the screw and nut mechanism. Okay, in this mechanism the rotary screw is there and the reciprocating nut is there. The reciprocating motion is converted into again the rotary motion is converted into reciprocating motion, which is, so here you can see that there is a punch. Okay, so this is the quite cheaper mechanism than the previous one where the motor, crank, connecting rods are required, but whatever the capacity, efficiency of this first mechanism, it will be always high, then this productivity will be always high comparatively the hand controlled mechanism. Okay, this is the manual mechanism actually, so it will have the poor efficiency and productivity. So the third alternative mechanism is a design engineer can go for the hydraulics setup, where he can use the various control valves and hydraulic cylinders, but where he can use the he can achieve the high efficiency and productivity, which is the again it is the costly and highly efficient mechanism. The alternative mechanisms are compared with each other. At this stage, the design engineer have to compare various alternative mechanisms, and according to the again cost which is included in the specification, he have to select the proper mechanism. Again, he have to compare the whatever the existing machines are there in the market. He have to do the study. He have to select the proper and correct mechanism, so that the whatever the productivity efficiency of the machine, that will be high comparatively the existing machines available in the market. So fourth step is a layout of configuration. So at this step, the design engineer have to prepare a block diagram showing the general layout of the selected configuration. So here I have taken an example of a automobile car. So here you can see that the car is the combination of number of systems, number of components are there. It includes the engine, including lubrication and cooling, fuel system, including evaporative emission, the ignition system, the electrical system, including starting and charging, the exhaust system, including emission control, the drivetrain, including transmission, clutch, suspension, steering systems, brake systems, and the finally frame and body on which all the systems will be mounted. Okay, so here at this step, the design engineer have to decide what kind of joining method should be selected, whether she should go for the riveting, welding, bolting. So at this step, the design engineer prepares the general layout of every component, and there is a finalization of joining, that is assembly, what kind of assembly or joining method should be adopted. At this step is decided. Next is the fifth step, design of individual component. This is very important step. At this step, the design of individual component or machine element is carried out. Okay, so it consists of following stages. So first stage is determine the forces acting on the component. So at this stage, the design engineer have to think about that, whether the whatever the component, whatever the individual component is there, that is subjected to the static type of load, or it is subjected to the dynamic type of load, or it is subjected to impact type of load. So according to that, he have to finalize the how many types of forces are acting on the a particular type of component. He have to work on the types of stresses induced on the component. Okay, so according to that, he have to do the static, dynamic and kinematic analysis of the individual component. After that, he have to select the proper material for the component depending upon the function requirements, such as strength, rigidity, hardness, wear resistance. Let us take the example of a connecting rod. Now the connecting rod is having it is working under the cyclic type of load. If you take the example of a connecting rod, also it is working at the high temperature. Okay, so the need is while selecting the material that for the connecting rod, the design engineer should think about the strength, rigidity, hardness. Again, he have to think about the coefficient of thermal expansion while selecting material for the connecting rod. Okay, so likewise, selection of proper material is required during the design of individual component is also important. Third is that determine the likely mode of failure for the component. Depending upon it, he have to select the criterion of failure, such as yield strength, ultimate tensile strength, endurance limit, or permissible deflection. Again, it depends on the type of load acting on the component. Okay, so here a designer have to go for the study of different theories of failure, like maximum shear stress theory is there, principal stress theory is there. Okay, maximum strain energy theory is there. Okay, so here the design engineer have to focus on what kind of stresses, whether the stresses are unidirectional or bidirectional or tridirectional state of stress is there. So he sometimes he may have to go for the principal stresses to design the component. So here design engineer have to work on the modes of failure of component depending upon the criteria of failure. Fourth step is determine the geometric dimensions of the component using a suitable factor of safety, and modify the dimensions from the assembly and manufacturing considerations. Again, at this step, the design engineer have to decide the factor of safety. The factor of safety is decided on the basis of there are three significance of factor, various significance of factor of safeties are there. Okay, so what kind of machine is there, how many lives are depend on that machine, so failure to property, loss to property, loss to life, many parameters are considering while selecting factor of safety. Again, what kind of load is there, whether the load is static, whether the load is dynamic, whether the load is impact type. So according to the load, according to the working condition, whether the component belongs to an simple automobile or whether it belongs to an whether it is a component of aeroplane, in that case we have to consider the higher factor of safety in case of an aeroplane. Obviously we need to go for the higher factor of safety in case of a car also. Okay, so according to the working condition, according to the type of load, according to the loss of life, loss of property, so many factors we need to consider while selecting the factor of safety, and according to that the dimension should be modified. Okay, so at this stage detailed stress and deflection analysis is done for the individual component. The sixth step is preparation of drawing. So at this step, after the completion of design of individual component, the design engineer have to work on the assembly and detailed drawing of individual component, which should include the part list, tolerances, surface finish values, grades and machining symbols, etc. The designer prepares two separate lists of components, standard components to be purchased directly from the market and special components to be machined in the factory. In many cases, a prototype model is prepared for the product and thoroughly tested before finalizing the assembly drawing. So here at this stage, after finalizing drawing, design engineer have to decide some components like nut, bolts are there, that can be purchased from the that can be outsourced or purchased from the other organizations, and some design which are the critical basic designs are there that can be conducted or carried out inside the organization. Again, a design engineer, after preparation of drawing, there is need of manufacturing of prototype model, there is need of testing of prototype model. After the testing of prototype model, if the prototype will work, it will work finely, it will satisfy the need of customer, there is no need to change the design, that design can be forwarded to the production department for the mass production. If it will not work as per the requirements of the customer, in that case the design engineer have to rework, he have to go again, he have to go in the previous steps of design and identify whether the problem is there. Okay, it is seen that the process of machine design involves the systematic approach from known specifications to the unknown solution. Okay, so actually the specifications are technical terms put, or it is the definition of problem according to the need of customer, and a solution is nothing but the drawing, okay, and a prototype. Quite often problems arise on the shop floor during the production stages, and design may require modification. Sometimes whatever the thinking of design engineer, that will not be feasible to manufacture inside the plant. Okay, so in that case the whatever according to the feedback of production supervisor or production engineer, a design engineer may have to change his design. Okay, in such circumstances the designer has to consult to the manufacturing engineering and to find out the suitable modification. So that's it. Thank you.